Have you ever felt like the real world is just messy? That the neat and tidy rules we learn don't quite fit? Well, you might be onto something. Today, we're going to dive into what's called the logic of fuzzy reality. And trust me, it's a concept that might just change how you see, well, everything.
All right, let's start with a classic puzzle. You've got a single grain of sand. Is it a heap? Obviously not. You add another. Still not a heap. You keep adding one grain at a time. So at what exact moment, at which specific grain, does that pile of sand become a heap? This little problem, it's a famous paradox, and it perfectly highlights this giant gap between clean, simple logic and the fuzzy way we actually experience the world.
You know, in logic class, they teach you this simple bedrock rule called transitivity. If A is the same as B and B is the same as C, then A has to be the same as C. Makes sense, right? But then you look at the real world. Imagine a paint swatch from the hardware store. One shade of green looks identical to the one next to it, and that one looks identical to the next one. But if you follow that chain long enough, the color you started with looks nothing like the one at the end.
So yeah, this is way more than just a fun brain teaser. It's a fundamental problem, and it has a name, non-transitivity. And it's basically a crack, a deep crack, in the very foundation of how we assume logic should work in our messy everyday reality.
Okay, so what is going on here? Why does this happen? Let's dig into the root of the problem, which is all about what we're calling our fuzzy reality. And here's the kicker. It turns out the problem isn't really with the world itself. It's with us. It's about the built-in limits of our own senses and our tools.
So old-school classical logic is built on this idea with a bit of a mouthful of a name, punctiform identity. Basically, it's the idea that any property of an object, like its exact color or weight, can be pinned down to an infinitely precise, perfect little point. It's a beautiful idea. It's clean, it's perfect, but it's just that, an idea.
Because in reality, we can't do that. We can't measure anything with infinite precision. Our best, most advanced scientific instruments have limits. Our eyes definitely have limits. So instead of that perfect little point, what we actually get is more like a fuzzy little blob, what's called an interval image. The true value is, well, it's somewhere in there. And this fuzzy interval is where all of our real-world knowledge actually lives.
And there's a really good reason our brains are wired to work this way. Think about it. If you had to consciously process every single, tiny, infinitesimal variation in the world around you, it would just be noise. It would be a complete sensory overload, what this quote calls the entropy of experience. So to survive, our brains have to cheat. We group things together that are close enough. We create categories. We have to, just to make sense of anything at all.
Which brings us to a huge central concept here, indiscernibility. Now this is super important. This doesn't mean two things are actually identical, down to the last atom. Nope, it just means that we can't tell them apart. It's a statement about our own limitations, not about the absolute reality of the objects themselves.
So, if our world is fundamentally fuzzy and based on these intervals of measurement, how in the world can we build a system of logic that actually, works with that? Well, some very smart people have developed a new framework to do exactly that. It's called the Logic of Indiscernibilities, or LID for short.
Now, the core ideas behind LID are actually pretty intuitive when you think about it. First, it gets rid of absolute sameness and replaces it with what's called metric equality, which is basically just sameness within a certain margin of error. Second, it just fully leans in and accepts that everything we measure in the real world comes in these fuzzy intervals. No more pretending. And third, it swaps out that old fiction of perfect absolute identity for the much more practical reality of measured indiscernibility.
All right, this is the real test, right? How does this newfangled logic actually fix the heap of sand paradox? Or that chain of colors? How does it stop that slippery slope of almost the same from just continuing on forever and breaking everything?
So let's just walk through it one more time. To our eyes, color A is the same as B, B is the same as C, and C is the same as D. Old school logic just insists, well then A must be the same as D, end of story. But we can literally just look at it and see that's not true. Our own eyes are screaming that the logic is wrong. That is the chain reaction we have to break.
And here is LID's incredibly elegant solution. It's called K-transitivity. It just introduces one powerful new rule. It says that chain of is the same as doesn't go on for infinity. It's only valid for a specific number of steps, a number we'll call K. After you hit K steps, the logical connection is just broken. The chain snaps. And just like that, the slippery slope hits a wall. It is stopped cold.
So what this really means is that anytime we say two things are equal or the same in the real world, it's never some absolute cosmic truth. It's what's called a K-identity. It's a practical, temporary kind of sameness that's only guaranteed to hold for a certain number of comparisons before it just breaks down. It kind of has an expiration date.
So then, what's the actual distance between that perfect, theoretical equality from a logic textbook and any real-world equality we can actually measure? According to this framework, that distance is infinite. They are fundamentally different concepts that can never, ever truly meet.
Now, if we accept this, if we really take this idea on board, it has some really surprising and profound consequences for our entire understanding of logic and even of truth itself. So let's explore what happens when we really fully embrace this fuzziness.
And whoa, the differences are radical. In classical logic, there's the law of the excluded middle. Everything must be either true or false, period. LID says, not necessarily. It allows for an in-between state. Classical logic also says that a contradiction, A and not A, breaks everything. The whole system collapses. But LID, it can actually contain certain kinds of contradictions without falling apart. We're talking about a completely different underlying structure.
So where does a system like LID even fit into the grand scheme of things? Well, it's considered an intermediate logic. It kind of carves out its own home right in the space between that absolute true or false world of classical logic and the more restrictive world of something called intuitionistic logic.
All of this leads to a pretty profound and mind-bending conclusion. Identity isn't some fixed property that an object just has. It is always relative. It's relative to our tools, relative to our senses, and relative to the precision of our observation. What something is fundamentally depends on how you look at it.
And that leaves us with one last provocative thought to chew on. Modern science is built on the bedrock idea that experiments are repeatable, that one electron is perfectly identical to every other electron. But what if perfect identity is just a useful, theoretical fiction? What if it's just a story we tell ourselves to make the math work? If that's the case, then how true are the scientific laws we've built on top of that fiction? Something to think about.